So in this lab, we will be working on a thermochemistry problem. Specifically, it's a calorimetry problem, and we are working with a cup of coffee. So the premise for this lab, and I don't have it on here just because it's already listed on the lab handout. I'm not going to sit here and read it, but the premise is that you're a barista and a professor comes in and asks for a cup of coffee with milk, but at a very specific temperature. So it is your job to make this cup of coffee at that very specific temperature. And luckily for you, you have some chemistry knowledge in terms of calorimetry. And just to recap on what calorimetry is, it's a technique where the amount of heat involved in a chemical or physical process is measured in a closed environment. In this closed environment, all the energy that is either gained or lost by the surroundings is equal to the energy gained or I forgot to write lost, but let's just say or lost by a system. No energy will be lost into the air. It's all kept in that closed environment. So that's why we can set these equal to each other. It's like if you gave your friend I don't know, $5 and they kept it and that's where it went. It didn't just get lost, right? Your friend got the money or something, or if you're sharing candy or something. And in our case, we can assume that the energy gained by the cold milk will be equal to the energy lost by the coffee, right? The coffee is the one that is hot, so it has thermal energy. Remember that temperature relates to thermal energy, the energy of the atoms and molecules in whatever solution or whatever it is that you're working with. So the coffee's hot, it's giving off energy to the cold milk. So we can set these equal to each other, and it's going to be in a closed environment because our coffee cup is completely insulated. And we also know that the definition, or that we can calculate heat of a system from this mathematical relationship. So the specific heat, the mass, and the difference in temperature, and then we can set these equal to each other. So if we have every single one of these, or actually 5 out of 6 of these, we can calculate for an unknown, right? In this case, what is our unknown is this mass. It's the mass of the milk, the mass of the milk. We can get the mass of the milk from the volume of the coffee that the professor is asking for. But we are searching for this right here. So that's your unknown. Keep that in mind. The general procedure for this will be that we are going to load the lab in the browser. You're going to read the prompt given. Now, each prompt that is given is unique to the web browser. So every time you reload it, you're going to get new values. So keep it loaded. Don't refresh it or anything. Keep it on that first page. Record the data that it gives you in your first data table. And then from there, you're not going to begin the lab yet. You're going to use this data to calculate the amount of milk. Remember what I said on the previous slide, what your unknown was, your mass of the milk. That's what you're going to calculate for. And then you need to convert to the volume of that milk. That volume will be the amount you need to make the coffee at that very specific temperature that is being asked for. You're going to assume the density of the milk and coffee are that of water, which is 1 gram per ml. You're going to assume the specific heat capacity of milk and coffee are also that of water, which is 4.184. After calculating is when you start doing your lab. And by this point, I know that you guys have enough experience with virtual lab so that I can give you these general guidelines and you can kind of conduct this yourself in terms of, oh, do I need a flask? Oh, do I need a beaker? I trust that you guys can do that and that you will explain yourselves in the description you give me of the procedure that you did. But just to give you an idea, you need to measure out the specified volume of the coffee and milk, and then you need to change their temperatures and make them close environments. From there is when you can add the milk to the coffee, and I'm going to go over it in the video, but just very quickly. And then finally, just verify that the volume does bring your coffee down to the desired temperature. So I'm going to show you specifically what I did. You can deviate a little bit and you'll see what I mean by deviate. But here I'm showing you that it's giving you a guideline here as well if you forget. Of course, we have our stock room. We have the coffee. I started with the coffee. You can start with the milk. It doesn't matter. I'm starting with a flask. And you know how like at Starbucks they get your cup and they put your name on it? So that's what I'm doing because I'm a barista, remember? Professor's coffee. And I'm getting it ready so that I can prepare that coffee, right? So next what I'm doing is my problem told me that I had 200 grams of coffee, and I converted that 200 grams to ml. So that's what I'm pouring out right here. Next, you need to insulate this system, and you need to enter in the specific temperature that the problem gave you. So for mine, it was 90 degrees. It told me that the initial starting temperature of the coffee is 90 degrees. Next, I'm going to grab the milk. And you also need to adjust the temperature of this. For my problem, my specific prompt, it told me it was at 5 degrees initially. So now you have everything ready to add your milk to your coffee, and they're both in closed environments, and they're both at the specific temperatures and that you're starting with. So next, right there, what I was showing was you can add the milk to the coffee. Obviously, I didn't add the volume because just in case somebody gets this particular set of volumes and temperatures, I'm not going to give it away, but at that point where you start adding the milk to the coffee, that's the volume that you calculated. So once you add it, since this is a closed environment, this temperature is going to be affected. It should bring it down to the specific temperature that the problem is asking for. For me, it was what? I think 75 degrees. So it should bring it down to 75. And if you calculated right, it will do that exactly for you. For the data collection, I already mentioned this. The first part A, you record the values that the website generates for you. You're going to do this twice. So there's 2 trials. So the second time, you just refresh the page and record those new values, calculate it again the same way you did it on the first one, and then report these values. For the applied exercises, you're just gonna, there's just more like practice of this particular subject. So you're gonna calculate grams of water using this equation. For part D, you need to determine if the reaction is endo or exothermic, and then calculate the heat that the water in the problem lost or gained. For both of these, you need to show your work, and you need to either insert a picture or you need to attach it somehow to whatever you turn in, because I need to know that you actually worked it out and that's how you got your value. Other than that, I mean, the lab part is pretty simple. It's just calculating that may take you a little bit, and then from there you just verify it with virtual lab.